Hi, Teddy Ann here in her Saturday best. I just finished running the first review session, and as I was queuing people up for work week number 5, I knew that I wanted to show you a regression equation or a regression analysis. And I was bumbling through it with the first group, and I thought, you know what, I'm just going to create a video, and that will help you see how you run a regression equation. So that's what I'm going to do here. I'm going to minimize me, so we don't have to look at me. And now I'm going to look at the database that I've opened up. I've opened up the salary database, as you can see. And to run a regression analysis on this is really quite simple. And you'll have good SPSS videos to look at about regression, and then also there's some explanation of it in the Peregrine module. But in SPSS, to run a regression equation, you simply open up a database, you go to Analyze, and then I'm going to come down here to Regression, and I'm going to ask SPSS to run a linear regression. In this case, I've already got the linear regression set up. I'm going to bring that window into our screen. Hold on, let me get it there. Here we go. What I've done is my dependent variable is beginning salary, so I'm showing you an example. And in this beginning salary, I'm going to take these out for right now, so I can show you what I was thinking. Out those go. I dumped a whole bunch in here as I was experimenting with this. But I was thinking about what kind of variables might have something to do with beginning salary. And I just dumped them all into my regression equation. What SPSS does is it makes it very easy for us to experiment with what kind of variables are impacting a dependent variable like beginning salary. So the first time I ran this, I threw in a bunch of stuff. For example, maybe gender of the employee is one of the factors. Perhaps it's educational level. Maybe it's previous work experience. Maybe it's minority classification if there's any discrimination going on. So I threw those in there and I ran my regression analysis. Just to show you how I set things up, I went to statistics. Let me pull that into screen. Hold on. There it is. Come on, all the way in, please. I want the regression estimates, confidence level. I'm not going to do that right now. I wanted to make sure that I have a model fit. So make sure that you have that box checked. Continue. So again, I went to statistics and model check and then continued. And then other than that, that's all I really needed to add to this. You don't need to worry about any of the other things here. Those are more complicated ways of doing this. And so I run OK. It's going to pull up my document or my output. I need to bring that into screen for you so you can see it. Here it is. And what it's telling me is it's first telling me here are the variables that I threw into my regression equation. The next thing it's telling me is how good of a fit the regression equation is. It's telling me how well did this model that I just created to try to explain the differences in beginning salary fit with explaining all the range of beginning salaries that are in this database. And the number that I'm going to key in on is this R-square of 0.499. What it's telling me is that if I converted this to a percentage, what it's telling me is about 50% of the differences in beginning salary are being explained by minority classification, sex of employee, work experience, and educational level altogether. The next thing it has for me is the ANOVA table, which you've learned a little bit about, and it's telling me that it is significantly explaining beginning salary, so I've got a good model here. And then what it's also then doing is looking at the coefficients. Basically what this is it's telling me that I have a regression model. Hold on, let me make this a little bit smaller. Get me out of the way. Thank you. Maybe I'll make me go away completely. I probably already am. Anyway, what it's telling me is that it's got a model where the constant is a negative 1300, and that's saying that and that it's significant. It's a number that we need to have in there. And then it's also telling me that the gender of the employee has a role in this, as does educational level, and as does work experience and minority classification. How do I know that? Because they all have significant values of less than 0.05. That p-value of less than 0.05 is telling me that all of these have some impact on the dependent variable salary. But I'm curious, is this the most efficient equation? Is this all I need to have in there? What if I start taking some of them out? So the way you do that is go back into Analyze, go back to Regression, go back to, stay on Regression, go back to Linear. I'm going back to what I had here. I'm going to pull out some of these and see if it makes any difference. So I'm going to pull out minority classification. So see how I pulled it out? And then I'm also going to pull out gender and see if it's going to change how predictive my equation is of just using these two variables, educational level and work experience, with beginning salary. So I'm going to go ahead and run that. And now I'm getting, where is it? Yep, there it is. Before, remember, I had an R-square of 4.99 or 0.499 or 50% of the variance was explained by this. And now I come down here, I run it again, and this time my adjusted or my R-squared is not that much difference. It's a little bit less. So it's telling me that having that gender in there or work experience or prior work experience is useful to this model. But what I really want to show you is, look what happens when I add a variable that we've explored before. Going back to, remember when we were messing around with this in the classroom, we discovered that employment category and work experience were very much related, and beginning salary was also related to work experience. So or job category. So let me put job category in there. And now let's see what happens to our regression equation. Remember the highest value I had so far of being a good equation was that 49.9. Then I pulled a couple of variables out and I got a 44.6. Now when I add in job category, the employment category, work experience, educational level, I suddenly get a R value of 0.696, which is about 70%, right? If I converted this to a percent. So by adding employment category, I am now explaining 70% of the cases that of the variance in the cases of beginning salary. What it's telling me is a good model to explain beginning salary happens to be a model that includes employment category. Why might that be? Well, remember when we looked at this before, we saw a strong correlation between beginning salary and the job category that people are being hired into. That makes perfect sense, doesn't it? Of course it's going to make sense that a beginning salary is going to be set by the kind of job that you are entering into. So to review, to get a regression equation, you go into Analyze, you go down to Regression, you choose Linear, you put into the independent box that which, I'm going to get rid of all of these so I can show you again. You put into the dependent box the variable that you are trying to explain. In your, for instance, it could be you're trying to explain job seniority or trying to explain current salary. In this case, we tried to explain beginning salary. Then you put into the independent box all the variables that you think are having an impact on the dependent variable. Make sure that you choose model fit and estimates. And then which nothing's going to happen now, but then you hit OK. So in this case, I did beginning salary. I threw in some independent variables. and ran an equation. So that's how you run a regression. Be sure that you give me a call or send me a text message if you need to have me talk to you about some of these things one-on-one. Thanks.